Hello, everyone. Thank you for joining us today for our ALS Webinar Wednesday series. My name is Alex Yao. I'm the Marketing Coordinator for ALS North America, and I'll be facilitating the webinar today. Just a few helpful notes before we begin. If you're having technical issues with our webinar platform or any questions, you can type your message or question using the chat function at the bottom of the screen. You can also select the hand icon to notify me of your status so I can assist you. All questions regarding the webinar material will be answered at the end of the presentation. Our presenter today is Quenton Beals. Mr. Beals brings over 10 years of tribology experience and OMA 1 certification from the Society of Tribologists and Lubrication Engineers. During his time at Phoenix Laboratory, he has worked extensively in all operational areas, including customer service, sample testing, equipment repair, report diagnostics, and account management. During his time as a diagnostician, he evaluated over 250,000 oil analysis reports. Mr. Beals has helped support clients over a diverse range of industries that include deepwater drilling, construction equipment, water utilities, and general aviation. Today, Quenton will be discussing how to read a test report and other data analytics. Thanks for taking the time to deliver this presentation. I'll turn it over to you now.
Thanks, Alex. I appreciate everybody being here. It looks like we've got a really good group of people, which is exciting. This is a great topic, so I'm excited to share it with you. I will offer a small disclaimer before we start. I live in very close proximity to an F-35 training base here in Arizona, so there is a chance when those fighters return from a training exercise that their pattern goes right over my house. So there's a slight chance that we might get interrupted, but we'll cross our fingers that doesn't happen. So thanks for the introduction, Alex. And to get started, we'll look at the agenda for today. So first, we're going to start out with a safety moment. ALS really prides itself in the effort that we put towards safety. Every meeting that we have with a group larger than just a couple people within ALS has a safety moment. And usually we like to review our different life-saving rules. So different areas of ALS, depending on what sector or division that we work in, we have different life-saving rules, and we'll review one of those today. Then we'll get directly into what oil analysis is and what tests that we do, because it's really important to understand before we try to read a test report why we do the tests and what those tests are trying to achieve. Then we'll get into reading those actual test reports. And then we'll get into data analytics, because that's really important as well. So it's great to know how to read a test report, understand what that data means on a sample per sample basis. But really, when you can combine all that data together and see what is going on across an entire program, that can bring a lot of extra value and can sometimes hint towards things that you might not see on an individual report basis. Then I'll go ahead and give you guys my contact information, and then we'll get into a summary and questions at the end. So to start out with our safety moment, we're going to review the life-saving rule of lethal chemicals and substances. So in ALS, that rule reads, all staff need to be aware of chemical substances that can kill and strictly adhere to all applicable control measures, including safe handling, storage, and wearing appropriate PPE. Within the laboratory, we do use various chemicals and substances. Sometimes they're toxic, other times they're flammable. So it's very important to understand how to handle these and what the safety procedures are. If there's a spill, if there's an accident, what's the proper fire extinguisher to use, perhaps if it's a flammable substance. And whether you notice it or not, we're surrounded by chemicals, and we often use them in our own homes. And this is something that I never appreciated until I worked in a laboratory and I went through safety training and I learned about control measures and handling and what proper protective equipment is for different substances. Then as I began to notice all the different chemicals that we have in our home, it was quite surprising, because it's not something that I learned growing up in the home. Obviously, you knew, how to be somewhat safe, but it's amazing the lack of training I felt like I had. And so I really would encourage everybody to, the next time that you go to use a cleaning product or a different chemical, or even if you've got, ATVs or motorcycles and you're using a gas can, definitely review how to safely handle those chemicals and wear the proper PPE. All right, so let's go ahead and get into oil analysis and the tests that are performed. Now, there's three different things that we look at when we test oil. And the first one is fluid condition and its properties. So we want to look at that lubricant itself. Sometimes it's a grease, but most of the time we're looking at oils. So these are engine oils, gearbox oils, hydraulic oils. Sometimes there's fire retardant fluids that are used. And we want to perform tests to make sure that the condition of that fluid, the product itself, is okay, and that it still is within, it still has the properties that it should have. One of the most important properties is viscosity. So the best way to interpret viscosity is it's well, the true term for viscosity is its resistance to flow, but in layman's terms, it's how thick is that fluid. So you can think about honey being very thick and water being very thin. They have two very different viscosities. And so we want to test that and make sure that it falls within its specification. And there's ISO specifications and SAE specifications depending on the fluid application. Next, we can do a spectrochemical analysis where we're looking at the metals, those elements that are inside the oil. For those that aren't very familiar with fluids, there's actually a lot of different elements that are added into a fluid, into a lubricant, to make sure that they perform, in the environment that they're in, whether it be an extreme pressure additive. Sometimes it's an additive so that they can handle the harsh environment inside of an engine. And so we want to test and make sure that those additives are there and that they're in the correct ratio for the product that's in use. Next, we can look at different parameters that sometimes those additive packages give, which is a base number. So a base number is kind of how alkaline, how much the fluid has the ability to fight off acid buildup. Then we have another test, which is acid number, where we can actually look at the acid building up in that fluid. We can look at oxidation occurring. So unfortunately, almost 99% of the time, all fluids are in an environment where they come in contact with oxygen. And as we know, almost everything oxidizes. Metals begin to oxidize. Well, fluids do the same thing. So when they're in an environment with heat and oxygen that can get mixed in, that fluid will begin to oxidize. And so we have a way, and it's actually the instrument that's there on the screen, which is an FTIR, and it uses infrared radiation that passes through the sample, and we measure the absorbance of different components. So we look at the molecular composition and structure, and so we can see those oxidation structures as they start to grow inside the fluid, and we use that instrument to look at that. Nitration is something that can be tested for. That's most common in natural gas engines. And next, we're going to move on to contamination. So after looking at it, does the fluid meet its properties? Does the fluid look okay itself? We want to look at, is there an outside contaminant that has entered into the system? Because there's various different ones that can be introduced. What we'll do is we'll use spectrochemical analysis to try and see if there's any elements that normally we don't want to see. Perhaps dirt, for example. Dirt usually has a really high ratio of aluminum and silicon. And so if we see those elements, we know that there's a possibility that dirt is being introduced into the system. We can also check for water. So if it's not a water-based fluid, because there are some that are out there are some water-based fluids depending on the application, but a lot of times in your engines and gearboxes, they're all, a hydrocarbon-based fluid, and water does not mix well with those. It's not good for that fluid to have water in it. So we want to test to see how much has been introduced, if any. We also check for coolant and fuel dilution and soot if it's an engine application. So we want to make sure not too much of those, what we would consider contaminants, are building up inside of that fluid that's in use. And then we'll do a particle count. So that's mainly geared towards hydraulic fluids. We want to make sure that the cleanliness rating is correct for the application. Perhaps, there's a servo actuated hydraulic system. Those have to be super clean. Or else those servos can be interrupted or have have issues. So we want to make sure that we can count all the particles in that fluid and make sure that it meets the specifications that the OEM has set out. Over to the right, you're going to see that Carl Fisher instrument. That's how we test water. What we do is we titrate in an iodine solution and we look at a reaction with the water that's possibly in that sample to determine what that concentration of water is. And we utilize ovens to separate the water from the lubricant. So if that water has gotten into that oil, we need a way to kind of pull that water out, and heat is a really good way to do that. So we'll put it into a vessel, heat it up, pull that water out, and then that vapor goes into a chamber that we then titrate. Next, we'll look at wear metals and wear debris. So this is kind of the third and last component of oil analysis. So after we've learned, okay, is the fluid itself okay? Is it meeting it? Does it have the properties that it should have? We've checked for contamination. Now we want to look at what is going on inside of that lubricated piece of equipment. So if it's an engine, we want to make sure that there's no parts wearing excessively inside that engine, because you have a lot of parts. There's valves, crankshafts, camshafts, pistons moving. There's a lot of things going on in an engine, and so there's always going to be some wear going on. You're always going to have some wear metals generated. So we want to monitor what wear metals are being generated and at what rate they're being generated at, because there is a level of what we would consider normal wear, something you'd see on a standard sample by sample basis. But then as those accelerate and change, or perhaps there's new elements introduced, could mean that there's a part wearing at an accelerated rate that we normally don't want to see. So what you're seeing there on the right is an ICP. It uses inductively coupled plasma, similar to what the sun is. So the sun is essentially plasma. So we're using the same thing, a plasma torch. We inject a sample through it, and it pretty much vaporizes the sample and any particles that are in there. And then we measure the intensity of light generated by the various elements there. And there's a really sensitive, pretty much a camera that's inside looking at all those wavelengths of light. And depending on the intensity of that light, we correlate that to a concentration, and then we report it back to you in parts per million. PQI is another way to measure wear metals and wear debris. So we use a magnetometer. It's pretty much a way to measure how much magnetism there is around ferrous particles, and it's a way to just check how much ferrous debris there could be within a sample. We can do a filter patch, so we'll pass the sample through a really fine filter and look at it under a microscope. That gives us a good idea of what kind of debris or wear metals are there. And then there's analytical photography, where we create a microscopic slide, and we're going to look at some of those pictures today. So the last thing, this is kind of probably the most boring slide that I've got today, but it's very important, and that's why I want to have it here, and I want to read through it, because ownership is really key to an oil analysis program, and essentially kind of the point of you wanting to read test reports is you have to have ownership of what those reports are bringing to the table. Because if nobody has ownership of those reports, if nobody's reading them, trying to gain information from them, then they're invaluable. They don't bring any value to your program. So what it says is establishing ownership of the test reports and equipment reliability data is instrumental in optimizing equipment reliability through a fluid analysis program. So it's important that you assign ownership of management of the reporting, data, and coordinating with reliability and maintenance staff, and the laboratory will ensure return on investment is also optimized. There should be an established internal procedure for report receipt by the end user that ensures the information gets to the right person that is responsible for equipment, lubrication practices, and data management. There should be a key individual that is able to coordinate testing services with the laboratory. So pretty much what that's saying is, if you're doing fluid analysis, you need to have somebody that's designated to take ownership of that. They're getting the reports and they're getting them to the right people. So if they've got a report that says there's a coolant leak in a truck, they need to get that report off to somebody that's going to be able to pull that truck out and perform maintenance and figure out what's going on, what needs to be repaired to get that truck back into working inside of your group. So it's really important that you understand that, while it's great to understand how to read test reports internally, you need to have a way inside of your business to ensure ownership of this data. All right, so now let's get into how to read test reports. So for those that are new, hopefully there's a lot of new people here that are going to be looking at test reports, for the first time, or maybe they've only looked at a few, and hopefully there's some people that have looked at lots and lots of reports, and we can all learn something new. So these are the PDF format reports that get emailed out. You can also generate them through our website, Webtrieve. You can go in there and look up a sample point and pull, any of these reports that you need. The PDF version has the 6 most recent samples, and as I stated, you can go onto Webtrieve and get any older history that you need. On the back of these is graphs. So we pick some of the most critical. We obviously can't include all tests because sometimes there's more than 30 tests on a report. So we can't include all, but what we do is we try to pick the most key elements and parameters that would need to be monitored, and we put those in a graph format. So it makes it a little bit easier to visualize trends, trying to get an idea of, over time, how is something changing. Sometimes it's not as easy when looking at a bunch of numbers, but definitely graphs really assist that. We list all of our US laboratories, so you know exactly, which one you're working with and who to call. And then we list out the test methods used, because it's really important when you go back to then talk with an oil manufacturer or an OEM, and you provide a report, or maybe you just provide a test result to them, over the phone. They might ask, well, what method was used to test that, because they need to correlate that with data that they might have in-house. So to get into more detail with these reports, what we've got over onto the left side of those reports is information about the sample point itself. So at the top, you're going to see a unique identification number. That's what that UIN number is. That's just a unique identifier that ALS creates for your sample point. It's unique. It doesn't change. It doesn't change unless it needs to maybe perhaps somebody sent in a sample and it was mislabeled, and we need to, merge 2 of the same, engine that got created by mistake. We'll merge those together, but that's a unique identifier. So you'll be able to call the lab and use that unique identifier for them to, reference samples that have maybe been processed, or you can even reference that yourself when submitting a sample. And that ensures that there's not a mistake made in terms of knowing which sample point it's for. Below that, you'll see unit information, so the unit number that you designate as a customer. Then there's make and model information and serial number information. All of that is based on what you provide to the laboratory. So if you don't put that on a form, if you don't go on the website and enter that information, the laboratory is not going to know what that is. So if you want to see it on the report, you got to make sure that information gets to the lab. Below that is the compartment information. So the best way to think about a unit and compartment is you can picture a truck, for example. So we'll picture, maybe a Ford F-150. That the unit is the F-150 itself. The compartments are its engine, its transmission, its differential. Maybe it's a 4-wheel drive, so it has a transfer case and a front differential. Those are all the different compartments. So each unit itself can have multiple compartments. So under that compartment, you're going to see what the name of that is. So whether it's a diesel engine, transmission, perhaps it's something else that has a hydraulic system. And then if you did provide any make and model information for that compartment, we will list it there as well, and then along with its capacity. It's really beneficial that information gets provided to us, because that really helps the laboratory interpret your results properly, because sometimes we do have specific data tables based on make and models. So for example, here we see a Detroit diesel DD15. We have a data table based on wear rates for that engine. So if it was just a generic diesel engine and we didn't know, we have to use generic data tables to understand, is this engine wearing at a rate that would be considered normal? But if we know that it's a Detroit diesel DD15, perhaps we can find something a lot quicker and understand if there's something that isn't correct. Below that, we'll list your customer information. Below that, we'll list the diagnosis itself. And so this is where, as Alex shared, for a couple of years, this is what I did. I was a diagnostician and I would review reports. So I would go through, look at the data, interpret it, and I would add comments. So these are the type of comments that we'd put. So here we've got all wear rates are normal. all the abrasive and other contaminant levels are fine. Viscosity is within its operating range, and the action is to just then resample at the next service interval. So this is a great report to get. Everything's normal, everything's fine. Just go ahead and sample again. We do list who that diagnostician is in case you need to reach out to the lab. And then we have a sample condition indicator. So on that bottom left, that is the overall sample condition for your latest sample. We've got normal, which is green, and everything's okay. A caution is going to be a yellow color, which is a note of interest. It doesn't necessarily mean that there's any corrective action. It just means, hey, you should take note of this. Should be something on your mind with this piece of equipment. If you do get an abnormal rating, which on the website will be shown as a color purple, that's just a minor corrective action. So it is something that we do expect some action to be taken to mitigate whatever the parameter or abnormal result is. And then we have severe, which is an immediate attention required up to and including inspection. So that's something where we expect, somebody to immediately go out, possibly shut down that piece of equipment and begin to take a corrective action based on whatever those results show. Up at the top of the header here, we've got the current sample, which is in the far left column, and then you have your 5 historical samples. And listed in the rows there, you have a laboratory number, and that's an internal lab tracking number. Because obviously we receive samples at the laboratory in a non-sequential order. They come from all different customers from all over the US and all over the world. We add a laboratory number just as a way to track those, and they're sequential as we receive them. Below that is the SIF number, and that's a tracking number that you can record on your end before that sample is submitted. So it's either at the bottom of your sample information form, or it's going to be on a bottle label that comes with your kits. And that's something that you can write down, record, keep in a safe place, and then utilize that to then call the lab, reference that to find a sample, or you can go on WebTrieve and you can type that tracking number in and find a report very quickly. Below that, we get into this specific sample information that you provide as a customer. So the time on unit is the length of time or distance the unit has been in service since new or since rebuilt. So if you mark that it's been rebuilt, usually we'll start that clock over. Then we have the length of time or distance that the oil has been in service listed below that. And then we'll list your lubricant brand, product name, and viscosity. It's important that that information is provided because then we can compare that against normal levels of whether it be an additive package or other physical properties. We can compare that to normal levels that we see for that product new. Oil added, just so this is understood well, this is the quantity of oil added during the last drain interval, but not at the change. So we know that when you change oil, you're obviously going to be changing out normally the entire sump capacity of whatever that component is. But what the oil added is during that oil change interval, maybe it's 6,000 miles, how much oil was added during that. So if there's oil consumption, so maybe that engine consumes 1 quart of oil every 2,000 miles, somebody might write on here that they added 3 quarts. And that's important for us to know at the lab, because essentially what that is doing is it alters the results, because what you're doing is particles begin to accumulate at a different rate when oil is added. It's kind of similar to when you're diluting something. So oil is burning off, you're adding new oil. So you could have where the oil condition is okay because you're adding new product. So that base number and acid number might stay at a normal level, but then those wear particles that can't go anywhere but stay in the fluid could be accumulating, at an accelerated rate. So it's important for us to know how much oil is being added to that component during the oil change, not when it was changed, but during that oil change interval. The time on filter, this can apply if it's changed at a different interval than the oil itself. So maybe you have a component hydraulic system where you're changing the filter multiple times before the oil gets changed. This is where you can record that the oil wasn't changed, and that oil age can continue to rise as that lubricant is in service. But as that filter gets changed, we can show it as changed and then record the hours that are on that filter. Then we will actually list below that whether or not the oil was changed when that sample was taken. And then below that is a customer work order number. Now that's something that you're able to provide as a customer. You can list it on the information form or when you do an online submission. And that makes it a lot easier for you when you're looking at this report to line it up against a work order that was performed maybe for like a PM. So maybe there was a lot of work done on a component, and that oil sample was just one small part of it. That allows you to then reference back to what other work was possibly done. Now, getting into the actual test data itself, we try to split it up so it's fairly organized and easy to understand. So as you remember at the beginning, there's 3 different things that we're looking at when we test oil. So we're looking at the physical properties. Does that lubricant, is it within the parameters that we'd expect? Then we're looking for contaminants, and then we're looking at wear, debris, and wear metals. Well, up at the top, you're going to see the metals themselves. So that's the spectrochemical analysis, and those metal concentrations are reported in parts per million. Now, one thing I've put there just to help people understand what a parts per million is that is 0.0001%. So it's a very, very small amount. And that's why we use parts per million, because at times there's a very, very small quantity, and that's how accurate those instruments are in terms of measuring how much metal is in these samples. Below that, we're going to begin to see the contaminants, and this is a mixture. So this is a mixture of some elements. You can see silicon, sodium, potassium there, and then there's some other physical tests such as water and coolant. So we kind of push those all together just to keep it organized for you. Then we have an additive section below that, which shows those metallo-organic additive packages that those manufacturers put in. And depending on what fluid's in use and whether or not you change, you're going to see those. You're going to see those change, those levels. So you might see the ratio between phosphorus and zinc change, calcium and magnesium. You might see more moly in a different fluid. And that's a way actually for the lab to identify whether or not you're using the fluid that you've identified, because there are times where a customer says we're using this fluid, but we come back and say that doesn't appear to be the fluid that you think it is. And perhaps it's because somebody topped up the system with a different oil that they shouldn't be using. So that's where it's really important to provide the laboratory the lubricant that is in use. Then below that are your physical and chemical properties of the lubricant. So we're going to be looking at viscosity, how much fuel is possibly in that sample if it's an engine, how much fuel soot is generated if it's an engine, and then looking at those chemical properties such as acid number and base number. Now we're going to get into some real reports. So these are actual live reports from customers. I've scrubbed all the identifying information from them, but it's important to look at real reports, not something that's kind of been made up, fake. I think it's really important to look at what's really going on with people out there that are doing oil analysis. And this is a pretty good example. There is a tiny bit of information missing. You can see over here, we do have a make and model, but we don't have a make and model of the engine. So we know what kind of truck it's in, but we don't know what kind of engine that Kenworth truck is using. So there's a little bit of missing information here, but we can see that they're providing us what type of fluids in use. They're providing us how many miles are on that truck, how many miles that they're putting on, on those oil change intervals. And you can see we've got some really consistent results here. These additive packages are very consistent. Now what you'll notice is for those that have looked at a lot of oil analysis reports, these additive packages aren't super duper consistent. They're not going to stay at exactly 14, at these exact ratios, sample to sample. You're going to see some variation as you see here. But those that have looked at a lot of reports will see that, this is a very consistent. You can tell they're using the same oil. All the ratios between the different elements are the same. We've got really good wear rates up here. They're very low. They're very consistent. And then all of the physical properties are very consistent down here. So this is a really good report. this would be something you could look at for just a few seconds and kind of move on, because there's not a lot of attention needed. Now we're going to look at another report from the exact same customer. And what you're going to notice, and this is something that we didn't look at when looking at the different columns and everything, but what you're going to see here is some results with boxes around it. Now, these are the results that would be considered outside of normal. So we're trying to bring attention to those results. And to know the severity of what those are, we look at the bottom of the column. So down at the bottom, we can see we've got a stop sign. So this is kind of a severe level of what we would see as dirt contamination. Now what's interesting here is aluminum is found inside dirt and is contributing to the metals count, but there is a good chance that some of this aluminum could be coming from the engine itself. It could be an actual wear metal. So it could be a mixture of both contaminant and wear metal at the same time, because a lot of these newer diesel engines, almost all of them are turbocharged, and aluminum is a fairly common metal that's found in some turbochargers. And so it's very possible that some of this aluminum could be coming from that turbocharger. So, we've seen, some of us that have, worked on engines or seen them, you've seen a turbocharger that's been dusted when dirt has gone into them, though they spin at very high speed. And when you've got hard particles like dirt hitting a metal that's spinning at very high speed, you're going to break off and cause wear there. So that all of that dirt and wear has nowhere else to go other than inside of the engine, and we capture some of it here in the oil. Now, what's interesting here is I'm going to remove these boxes. What you can see here is this iron level is still considered normal for a diesel engine. It wouldn't be what we would consider alarming. But what's really interesting is we know this is the same customer, and we know this is a Kenworth. So there's a slight chance that it could have a very similar engine to the sample report that we were looking at before. So when we go back and look at that one, we can see the iron level is fairly low. It's around 10 to 11 per sample, and they're running fairly similar time on oil, which is about 8,000 to 9,000 miles. Now, what's interesting here is even though these are considered normal wear rates for a diesel engine, and each engine is going to be unique, so they're not all going to have the exact same wear rates, but it is interesting to note that this wear rate is higher, 3 to 4 times higher than the one that we're just looking at. So you could interpret that this engine is wearing at a rate 3 to 4 times higher per oil change than the previous engine. Now, what that does in terms of the life of that engine, I don't know. That's something where all we can really look at is oil analysis data, but it would be interesting to watch this engine if it was not addressed over time. How would the life of that engine be shortened if those wear rates are 3 to 4 times higher per oil change? It could continue to wear. The wear could continue to accelerate, and then that engine could have a significantly shorter life. So this is an example where guaranteed this truck is running totally fine. Whoever's driving this truck probably has no idea what's going on. It's probably operating perfectly in what they expect. And so this is where oil analysis is really important, because we see things that the operator maybe doesn't. Now, another thing to note here is obviously we've got multiple reports that say there's an issue, but it hasn't changed. So then the question comes to who has ownership of this report? Who has ownership that's getting these, that's saying, here's an issue and then we need to try and resolve it? There's a really good chance that the intake system of this truck just needs to be reviewed. Perhaps the oil filter has come loose, or the air filter, the air filter itself has come loose, or maybe there's a leak somewhere in the intake that's allowing dirt to be ingested. And so it could be a very quick inspection. It could take a little bit longer, but it really just needs somebody to take ownership of it, to say, what is going on here and how do we correct it? Because if it's left alone and this engine continues to wear at this high rate, it could significantly shorten the life of this engine. So go ahead and get these boxes and we'll move on to our next report. I'm hoping we're gathering some questions for the end. I'm looking forward to answering questions about that you guys are coming up with as we look at these. Now, here's a report where we've got an engine, and you can notice here in the middle, that we're starting to get some boxes here, and they're around some contaminants. And what we've got here is we've got sodium, potassium, and we've marked coolant as yes. Now, sodium, potassium are common elements that are found in antifreeze and coolant. And when we see them in a diesel engine oil, it's pretty much a true sign of a coolant leak. We know that that coolant is being ingested into that engine in some way. Now, you have to be careful because sodium can be found in gasoline engine oils. So when using sodium by itself, you got to be a little bit careful. You got to really look at the application and what oil is being used before you really jump on it's got to be coolant if it's sodium. Now, one thing is not present here is water. And for those that have maybe looked at a lot of oil analysis reports or that are familiar, you probably understand why. But perhaps there's some people here that are maybe scratching their heads because we know that coolant, most coolant is 50% water and 50% glycol. So if you're getting coolant ingested into an engine, how come there's no water? We've tested for it. We've shown that there's really no detectable water. What's going on here? Well, this is kind of one of the fun things about looking at oil analysis reports is because it takes you down a path of trying to understand all the things that are contributing. And so for a diesel engine, it comes back to what is its operating temperature. So an engine runs really hot, that oil gets hot. Now, the oil doesn't necessarily have to get up to the boiling temperature of water to have that moisture released. But as it gets higher and engines do run warm, that moisture is going to begin to be, in a way, cooked off. And so that's why there's no water left over. So as coolant's ingested into the engine, the heat of the engine is able to extract the water, and all that's left behind is the traces of water or the coolant, I should say, which is that sodium and potassium. Now let's move on to this one. Now here we have a report with a caution rating on the most recent sample, and I'm going to go ahead and show you down here at the bottom. So we have a base number of 2.9, which is starting to get below the recommended limit just for a generic diesel engine, and we've put a caution note on here. Now, some of those that might be new to looking at oil analysis reports or even oil analysis in general might go, okay, well, maybe we're running the oil too long, because as you use oil, that base number goes down. We're utilizing the additive package of that oil. One might begin to think, oh, we've taken this oil too far. But in reality, what you have here is, in my opinion, what you could almost consider a perfect report. And I know it sounds a little counterintuitive, but if you think about somebody who's operating diesel engines and they're trying to maximize their oil intervals, and sometimes those can go past the recommended interval depending on how those trucks are driven, what type of environment they're in. If you've got a really good oil, you can actually extend those drain intervals out. So what you've got here is you've actually got an oil that you've taken right to the kind of the limit of what we would consider normal. But what you have here is you have all of these other parameters that would be considered within range. There's no abnormal wear when we compare it to all of the past reports. There's no excessive contamination, and all of the physical properties are right in line with the history. And so this is actually a really good report to get, because you haven't gotten to the point where that oil is causing an issue, but you're maximizing the life of that fluid. So it's always important to kind of review and think about, okay, what does this result actually mean? Because sometimes, even though we're noting something at the laboratory level saying, hey, here's something that you need to take note of, sometimes it can be interpreted as a positive thing. So what this customer can now do is they can say, before, as you can see here, I was running maybe a little less than 20,000 miles. I took it to 30,000 and I just barely crossed into where that additive package is maybe starting to be depleted. They've learned a lot. They've learned a lot from this oil interval, and perhaps for this unit and truck and engine, this is a really good interval. Now, it's important that they continue to do oil analysis because things can change. The environment that truck works in, perhaps if they change to a different fluid, they're going to need to continue testing. But I always find it interesting to look at these and really share at least my point of view that sometimes this can be a positive thing. This can be a positive report, although it's not normal. So next, we're going to get into an MPE, or an analytical photography report, and these are really interesting. So I'm kind of excited to show these to you, because this might be something that not a lot of you have seen before. Now, this is a grease from a slew bearing on an offshore rig, most likely from a crane. So a slew bearing, if you can imagine it, the cranes that can turn and swivel. So you got the big arm that comes out, and they obviously need to spin that crane so they can pick up things. Well, there's a bearing, a slew bearing, that crane is mounted on top of, and there's a gear on the inside, and there's a motor that turns the gear, and that's kind of what swings that crane around. And so there's a really large bearing. Sometimes they have roller bearings. Sometimes they're ball bearings, and they have seals on them to keep them clean. Now, these are grease lubricated, and testing greases can be a little bit difficult because they don't distribute wear particles homogeneously. So because they're so thick, it's not like an oil where you can mix an oil up and you can evenly distribute wear particles within them and then do testing to figure out what's going on. It's kind of hit or miss. And so as you can see here, we've done a spectrochemical analysis, and there's nothing really that sticks out. We kind of have wear rates that are going up and down. They were, whoops, sorry, I misclicked. So we can see some higher wear rates here, and then they've dropped down. So it could be a question of, is there a problem? It's really hard to get an idea as if there's a problem just for this. And that's where the analytical photography comes in. So as I mentioned before, what we do is we create a microscopic slide. So we just take part of the sample, we distribute it across a glass slide that goes over a magnet. And what that magnet does is it aligns ferrous particles, so that way we can kind of get an idea of what's ferrous, what's not ferrous. And then we look at it under a microscope, and we magnify it up to 500 times. And what that allows us to do is we get to see what the morphology of those particles are. So we can kind of get an idea of what the wear mode is that created them. Was it cutting wear? Was it rubbing wear? Was it fatigue wear? Was it abrasive wear? So there's a lot of different types of wear. And when you can actually see the particle itself, you can get an idea of what caused that particle to be generated. And so what we have here is we had these very large particles of fatigue wear. Some of these are over 100 microns in size. Now, when we do spectrochemical analysis, we're really only looking at particles that are below maybe 8 microns in size. We're looking at very, very, very small wear particles that are being generated right in the beginning of those wear modes, where here we have a very accelerated wear that's going on. It's generating very large particles. These are visible to the naked eye. So below about 40 microns, you can't really see with your eye. So those particles that we're testing in the spectrochemical analysis here, these particles, these you can't see. You can't see any of these particles. These are microscopic. But here, these are particles that are big enough to see with your naked eye. So this is really interesting. So whoever is maintaining this bearing is really going to get an idea of what possibly is going on. And we have some really great analysts in Phoenix that do a lot of analytical photography, and they've provided an interpretation here that really shows that there's a lack of lubrication that's going on. There's some black and red oxides that are being generated, which is usually an indication of lack of lubrication. And then obviously these large wear particles, if there was proper lubrication, you wouldn't be seeing these large fatigue and cutting wear particles. Now there is some dirt. So the big question for whoever is maintaining this crane is, where is that dirt coming from? Is there an issue with the seals themselves on those slew bearings? Is it allowing dirt to be ingested? But then the other question is, could the grease be the source of dirt when it's being added? So perhaps they have a bucket of grease, the lid is being left off, it's in a dirty environment. Then when somebody goes to take that grease in and put it into a lubricated system, they're putting all the contaminants that have then gotten into that grease into that system. And so this is kind of where it can start the investigation is, okay, we see that there's a problem. We see there's dirt. There's a lot of wear going on. How do we start to track that down? I'll share a short story of a situation that we ran into with grease. And this is something I personally dealt with years ago in Phoenix. There was a mine that was doing analytical photography, and on one of their components, we had done photography just like this that showed that there was cutting wear. And you can actually kind of see some cutting wear here. There's these long stringers. So as it cuts into the metal, it kind of creates these long stringers. Well, we had something that had some cutting wear, and they really didn't feel like it was possible for the system. They did their investigating, and they really didn't understand where that cutting wear came from. And they ended up sending us a brand new tube of grease from the same lot that was being utilized in that component. So it was a brand new. I received it myself. I got to peel the seal off of that new grease, and we did a microscopic particle examination on that new grease. And what we found is the cutting wear was in the grease. Now, for the manufacturer, what was probably going on is the pumps that are being used to transport that grease. It's very possible that they had a it's probably a gear pump that was being used to move that grease. They probably had some wear going on in those greases as they were being moved through the manufacturing facility. So it was fascinating to see what this analytical photography can do. And sometimes it really does benefit testing new fluids and new greases, because sometimes that's a source of wear and a source of dirt and contamination are those new products. So it's really good to kind of make sure that you're testing both ends of the spectrum to make sure that good clean product is going into your system, and that what you're getting in your oil analysis results is truly representative of what's being generated by the piece of equipment. Now, I can't get into all of the details of, it would take a long time, of what metals are generated from what different components, but we have a great resource for learning more about individual tests as well as other parts of the report. So I'm going to leave this up here on the screen just for a second. You can go to alsglobal.com/industrial report. That will give you a tool of how to read a test report, and it does give you that element by element specification of what are possible sources. And then we have an engine report specific one at alsglobal.com/engine report. And I'll go on to a screenshot. This is what it looks like. So back in the background, you can see there's a test report. That's what it looks like on our WebTrieve site. And on the website, you can click on the little yellow dots, and they're kind of spread all throughout the report. And it will have a pop-up that then details kind of more information about that section of the report. And what you can see here, when you get into the metals and different testing parameters, it will give you element by element specifics about possible sources. So if that's something that you really have a question on, it's a lot of information that it would take me a long time to go through, and it really is specific to the application. So one of the best sources is to talk with your OEM of your equipment about the specific component. So if it's a final drive on a piece of construction equipment, talking with them, what are the different types of elements that are in here? What are the metals that are used in the bearings? What are the metals used in shafts? And you'll get an idea of what different metals you'll probably see. But this is a good starting point. So definitely take note of these URLs and utilize them to help if you've got more questions. Alrighty, so next we're going to get on to data analytics. So as I said at the beginning, it's really good to be able to understand how to read a test report, understand what kind of information that you can get out of that individual report. But a lot of times, if you're a manager, maybe you're managing a big fleet and it's a diverse fleet of equipment, it's important to understand maybe what are some of the things that are contributing holistically to your fleet. So we have a few different scheduled reports. These go out by email on a monthly basis, or you can go on WebTrieve and generate them whenever you want. So we're going to just look at one slide per report. I won't name them all here because I'm going to name them as we look at them. So the first one is our condition summary report. So what this does is it offers some pie charts that create some, some clean visuals. They show the percentage of various report severities as well as the problem codes. So as you can see here, we've got the condition summary. So what percentage were normal, caution, abnormal, and severe. And then over here, we can see what kind of problems are contributing. So this is really important as well. It's, am I having mostly oil issues? How much is coolant contributing to my equipment? Is wear a major issue? And so what's nice about this is you can really prioritize at a program level, at a company level, what should be the biggest focus? Because if hey, look, oil is our biggest issue. We can kind of put these on the back burner for right now, but we really need to tackle what's going on here, what's causing most of our problems. This really helps focus your attention. Below that, you'll see that we've got some model specific information. So this is really great for managers. Some of you managers that have diverse fleets, maybe you have all different types of trucks and engines. This is really great to see because based on their application, maybe there's a superior engine that's great for long haul. Maybe there's a superior engine for short haul routes. This is a really good way to kind of understand, who's contributing to most of the problems that I'm dealing with. Next, we've got our sample activity report. This has got to be one of my more favorite reports because of how much information you can get out of it. And what it does is it creates a really good heat map of the last 12 months for you. You can see every single sample point. You can see every sample point here. You see the last 12 months, and you can see for every month that a sample was received, what was the condition? Was it normal, caution, abnormal, severe? Now, what's interesting right here, this column is a resample period. So if you've designated a time that you want to take samples, whether it be every 30 days, such as here, or here it's just once a year, what we then do in this report is we look at how many were processed. So for this air compressor, there was 5, but there was 12 scheduled. So over on the far right, we know that there were seven missing samples in the past 12 months. So this is really great for a manager, again, to go back and say, air compressors are really key to our operation. We need to be taking samples every month. Hey, this one is not being taken. I know exactly who I need to chat with about, hey, we're missing a lot of samples. We could have had a failure. That air compressor could have failed in November, December of 2019. They wouldn't have had a heads up because the last time that they tested it was in September. Then it does give you an idea of how many online submission samples were submitted. And how many possibly paperless reports, and then what the current status is. So this is a really great way to be able to scroll through and say, what are the components that I have an alarm on? So, oh, okay, here I've got a mud pump that has an alarm. That's its latest condition. I know I need to address, get some attention here. Now, there are a couple other tabs that are on this spreadsheet that we send out on a monthly basis, and that's an alarm list. So it just lists every sample point that's in alarm. And then there's a double alarm tabs. So you can see down here for that mud pump, see how there's 2 abnormal samples? This would be on the list of double alarms. And that's really great for trying to get an idea of, was there a problem and was it resolved? Perhaps the resolution, the first go around, wasn't the correct one. And so that double alarm tab that we include is really great for identifying, was the original corrective action good enough to resolve the issue? Because if it wasn't, maybe it caused a different issue or the same issue is persisting. It's great to be able to identify it quickly and get back on it. Next, we've got our delinquent report. This is just a really simplified way of understanding how many samples are missing. So as on the previous one, we know that you can define a sample period. This just emails you, lets you know how many of those sample points are overdue, when it was last sampled, what the sample period was, and how many days overdue it is. So also really great for a manager that's trying to really keep up with their oil analysis program. You can send this off to your team and let them know, hey, here's all the places that need a sample taken now because they're overdue. Last but not least, we've got our missing information report. So as I described in the beginning, getting information at the laboratory is very critical to providing good interpretation. Now, obviously, you on your end, you have all the information about your components. So when you go to read your report, you'll probably be able to get a little bit more into the details about what might be going on because of your knowledge of that component. But all of the extra information that we're provided on our end, we can help supplement the knowledge that we have to the diagnosis on the report. And so here you'll see it just highlights for every sample that we get what information is missing. Perhaps we don't know what the unit make and model is. Perhaps we didn't know how much time was on the oil. That's why it's really important to include that information. So we have a monthly report that goes out to let you know what's been missing. One thing that's really important to us is how easily we can get our data to you. So we've developed our web API. So it's our WebTrieve API. And what this allows you to do is integrate your EAM or CMMS directly to our WebTrieve platform. And it allows you to do your own reporting or possibly add data points for machine learning. We know that machine learning is becoming it's bringing a lot of value because as you get more and more data points on something, it begins to learn and identify correlations that maybe we weren't able to. And so being able to take oil analysis data and push it into a system that's already maybe doing machine learning using other data that you have, this can supplement that. So some of the features that it has is ad hoc sample reporting. So you can see here on the top left, you can get a JSON response from our API. It can be interpreted and pushed into either Power BI or Excel or any other reporting program that you're using internally. So maybe you just want to generate reports in your own format or supplement it with other data that you have on your end. You can use our web API to do that and streamline it. Next is automated and scheduled data loading. So perhaps you want to push our test data into your EAM or CMMS or into that database that's maybe has some machine learning done on it. You can use our API, push it into a SQL server or into some other databases that you might have. Last but not least is our automated sample submission. This is really cool. What you can actually do is integrate our API with your system to do sample submission. So right now, most people are using the standard paper forms, and that's fine. But there are more digital ways of submitting samples. So you can actually go on WebTrieve and submit a sample. You can use our mobile app, which hopefully we'll do a webinar in the future showing how you can do sample submission through the WebTrieve site and then through our mobile app to really streamline and ensure that data is getting to us quickly and efficiently. But the really neat thing about our API is in your own management system, whether it be maintenance management or asset management, you have a lot of data around the piece of equipment that you're sampling, perhaps how much time is on it, how much time is on the oil, what data PM was done on it, what the work order number is. So you already have all that information. And instead of having somebody go and seek that information out, you can have that system talk to WebTrieve through our API and say, hey, we're taking these 10 samples on these 10 pieces of equipment. Here's all the specific information about those samples in terms of time on the oil, what fluid is being used, what the work order was. And our WebTrieve system will send back to you either a label template, which is kind of what you can see here. It's a little bit too small, but if you want, we can send you back a label template with all that information on it, which you can then print and adhere to the bottle. Or if you've already got bottles and forms with a tracking number on it, you can just say all of that information correlates to this sample with this tracking number. And then we retain that information. When we get that sample in, we scan the barcode and we pull all the information that you submitted to us. So it's a really great way to streamline the entire sample submission process. So here's my contact information. I work out of Phoenix. I do go into the Phoenix lab quite frequently. I miss kind of being hands-on at the operation there, but it's been really great working more in the business development side and really working closer with customers. So we've got the office telephone there that you can reach me at, and then also my email, which is probably the easiest and quickest way to get a hold of me is through my email there. And as a summary, I'm gonna put up those links one more time to those tools. So we've got the industrial report tool, we've got the engine report tool. So go ahead and write those down so you have them. And then one last thing I will say is don't be afraid to consult with your equipment manufacturer or your fluid manufacturer or fluid distributor. So maybe you're ordering lubricants through a marketer, through a lubricant marketer. Don't be afraid to to work with them. Everybody has their strengths and the knowledge that they've gained over their careers, and it's important that you reach out and try and leverage that in every area. So here at the lab, we're going to have knowledge that we've gained over the years about oil analysis and how it can be interpreted and different things we've learned from other customers. Your lubricant marketer or manufacturer is going to have vast amounts of knowledge based on how their lubricants have been utilized in the market. And then your equipment manufacturer, they know their equipment best. They know how it was made, what type of lubricant should be used. Kind of through their R&D, they're going to understand what problems they've run into. And so if you can kind of bring all that together, you'll really be able to solve problems and leverage oil analysis to its maximum. If you do want to get set up with monthly management reports or the web API, definitely reach out to our ALS Tribology client support email that's there. You can send them an email. They'll find your account and get you set up with any monthly management reports or get you set up with that web API. And now we kind of went a little long, but hopefully it was good. And now we'll get on to some questions. Hopefully we've got some.
Thanks, Quentin. So yeah, we're going to open up the forum for questions now. If you could please write your question using the Q&A function in your toolbar at the bottom of the webinar. Attendees can also see all submitted questions using this window. I'll give everybody a couple minutes to type in their questions, and I'll review some brief notes at this time as well. This webinar presentation has been recorded. All participants of this webinar will receive a follow-up email once the recording is available to view. We also post our webinars on our ALS Global website and our ALS YouTube channel in the webinar playlist. I encourage you to find a wide range of video resources and past Webinar Wednesday presentations available there. Also, please follow our company page on LinkedIn as we post announcements and registration links to future webinars and other valuable resources and updates. So it looks like we already have a few questions.
Yeah, let me, I've got them up here on my screen, so I'm going to kind of read through. Okay, so we've got a question. It kind of came at the beginning. Ryan, hopefully Ryan's still here. Or did that get answered, Alex?
No, you might want to check.
Perfect.
Yeah, you might want to check that answered tab as well.
Okay. All right, I'm going to go ahead and just read it. All right, so I've always thought having brand new fluid, whether it be engine oil or hydraulic oil, be tested as a baseline for future comparative analysis to used oil. So Ryan, really good question. So a lot of times the lab itself has tested brand new fluids, so we are going to be able to know what those parameters are. The benefit to you as a customer submitting a brand new fluid is, one, you're going to get an idea of your specific batch of fluid, which is really great because it's very rare, but perhaps there is a contaminant that's in there. Maybe the drum or tote got water in it just from being stored. There's a lot of little things that can happen, and so it's great to know your specific fluid that is being used in your equipment, what it looks like. So that's one of the benefits of, yes, sending in yourself a brand new engine. Have you considered generating a database of new engine oil analysis, say a lookup for Mobile 10W20? Interesting. That's an interesting question. Usually the way that it works is we provide reports for whoever has paid for the analysis. So obviously you as a customer can obviously go out, buy whatever oil you want, pour it in a bottle and have it tested. Because we test so much, that could be something. I don't really know. I don't really have an answer for that right now, but it is something that I might ask about because that is an interesting concept. We've got a question from Vladimir here. What interval of new oil data for metal contamination additive parts to tell this data is not normal? So Vladimir, we get that data from two different places. So one, we can get it directly from the OEM. So the oil or the original equipment manufacturer will provide it to us. So they'll say, here's what we expect to be normal, wear rates. Here's what our contaminant limits are for this specific component. But then there's other times where we will internally within ALS create our own generic limits. And what we'll do is we will look at different specific types of components. So whether they be diesel engines or hydraulic systems, and we generalize that data and trying to get an idea of kind of generally what would be considered normal. So that's where we will utilize that when not enough information is provided by the customer. So if we don't know the make and model, we kind of just have to use a general level of what is considered normal. And what we do is we utilize millions of samples of data that we've done over many, many years to generate what would be considered normal. Does plastic show in a hydraulic oil report? This is Roy's question from a little earlier. We have seen HYDAC filter breakup on filter change, wondering if this is contaminating the oil. Plastics, it's a really difficult one because some plastics don't have elements that are going to show up spectrochemically. Just because of the way that they're made up, the specific elements that we test for aren't really compounds of those plastics. So we wouldn't see it there. The one place you would probably see it is in a particle count. So specifically on a hydraulic, probably the best way to see is if there's a particulate, because obviously that's essentially what we're trying to figure out is, are there particulates from that filter breaking up contaminating the system? I would suggest that as the best solution is doing a particle count and trying to get an idea is it going up over time? It's a little bit tricky though, because obviously you're going to be I'm thinking through this as I'm talking, so I apologize. But as you're putting the new filter on, it's possible that then those particles are then just going to get recaptured in the new filter that you've put on. So that would be an interesting one, Roy. You might want to reach out to a lab and kind of chit chat about, could there be a way to test in a way that could, before the filter captures those particles to figure out if they're in there. All right, we've got another one from Vishnu Sarkar. As the engine is closed, how water vapor escape from engine? So good question. So not all engines are completely closed to vapor. That moisture is eventually going to find its way out. There's actually moisture that's created in the combustion process itself, and it's taken out through the exhaust stroke. So good question, but yeah, the water vapor eventually does find its way out. Ryan Walsh asks, what can we look at to determine if the oil change interval is appropriate? Meaning, how do I know if I need to shorten my change interval? And conversely, how do I know if I can lengthen it? So we kind of got into it when we were looking at that one slide where what you're looking for, if you need to shorten, is if there's adverse effects in terms of not the. So I want to be careful about how I explain this. So you want to make sure that there's no adverse effects in terms of wear. So you want to make sure that the component isn't wearing excessively. You want to make sure that there's not too much contamination being accumulated, because what happens is every time you change your oil, you're flushing all the contaminants out. So if you run it too long, those contaminants can build up. So you want to make sure those contaminants aren't building up too much. And then in terms of the physical properties, you want to make sure that those aren't changing drastically. Because as I showed on that one report, you have a TBN, that base number, that additive package, which is starting to get to the end of its depletion, but we still know that viscosity was within range, and that there was no adverse wear. So what you'd want to look at is, if you continue to push that oil on a longer life, you might see that oil start to oxidize excessively and the viscosity increase and take it out of its viscosity range of, I think it was a 1540 that was in use. It might take it into an SAE 50 range, which could have some adverse effects. So that's really what you're looking for, is you want to keep your oil intervals short enough to where those changes aren't occurring, but you can lengthen them up to the beginning of those changes. And you might want to be a little bit more conservative You don't want to push it right up to that limit. You want to be slightly conservative in that. Somebody asked, they got a caution because of elevated PQ index. What is PQ index? So PQ index is looking at the ferrous content of that sample. So, and it doesn't matter what the size of the particle is. So when I was reviewing the analytical photography, where we could visually see those large particles, I was explaining that the instrument that we use to test for those particle, or to test for all of the different elements, it really is looking at very small particles below 10 microns. But we know that within gears and different systems that very large particles can be generated. And so the key to the PQ index is looking at any ferrous content regardless of size. And so really it's just looking at the amount of iron. So if you have a high PQ index, but your iron, your ppm of iron above that is low, you probably have a lot of very large ferrous particles or iron particles that are inside of that sample. We got a question regarding aircraft engine. Okay, here I have an aircraft engine that has regular oil analysis from ALS. Last analysis suddenly had high silicon content in the oil. This was not flagged as an issue on the report. Do I need to be concerned about this? So usually the reason we'll ignore high silicon when maybe there's no other issues such as wear is sometimes it can come from seals. So a lot of times silicon is used, or you'll have silicone seals used within an engine in different places. And what happens is the silicon element itself will leach out of that seal from the silicone itself into the oil. Now, it doesn't cause any wear issues. So if you see maybe higher silicon, but no wear and no aluminum, usually that's an indicator of it's just leaching from a seal. We've got some questions regarding differences between different sample kits. Looks like those are for like a branded fluid program. I'd encourage you to reach out to the lab about that. That way they can kind of go over those individual tests, Joel, and then they can give you pricing for that. Thanks, Tom. Appreciate your comment. Question for the end. Many times we may not know what the oil is in a compartment or even how many hours are on it. What is the best practice in sample submission for when those details may not be available? Jerome, it's not a huge deal if you don't know, if you you absolutely just have no way to know, it's totally fine. Just submit the sample. We're going to do our best to interpret it. Obviously, if the wear level is considered just high in general, we're going to go ahead and let you know. I'm assuming if you don't know how many hours on it, possibly it's been in use for a long time. And so that's a good thing to consider, is if you get back a normal report, but you know that there's maybe a lot of hours on that oil, that's a good sign. That means at least everything's okay. If it was a really short interval and the wear levels were kind of higher, that's where you'd kind of want to be maybe concerned and call the lab and say, there's a really short amount of time on this fluid, even though that the wear levels you say are normal, would it still be normal based on a really short amount of time? Jerome also asked, what would be the most efficient way to submit multiples of samples? Many times we have 20 plus at a time to do, and filling out the paperwork by hand is time consuming. So I think I'm going to have to do a webinar based on sample submission on Webtrieve. So Jerome, through our Webtrieve site, you can actually go on, and if you have your equipment uploaded into our database, you can select 20 to 40 different sample points. You can hit submit all at the same time, and it gives you 20 different rows, and you can hurry and quickly and type in how many hours are on the fluid, whether or not it was changed, and then you can submit them all at one time. And the beauty of the website is you can actually just type in the tracking number that's on those paper forms, and you don't have to print anything out. You can just type in the tracking number from the paper form, submit all those 20 samples. All you have to do is make sure that paper form lines up with those bottles correctly and send them off to the lab. When we get those, we'll scan that barcode at the bottom of the paperwork, and you're done. We pull all the information that you put in on the site. Looks like I'll have to do a webinar about that because it seems like it'd be a good one. What process do you recommend for sampling lube oils? That's a good question. Probably need to do a webinar about that. To be really quick, you want to do it at operating temperature, as close as you can to operating temperature. So if it's an engine, you want to heat it up, and as soon after shutdown as you can, take that sample. You want to take it in the same way each time, and you want to minimize contamination. So you don't want to take a sample into a dirty bucket. You don't want to use a piece of cardboard to help guide that sample into a bottle. be careful of, I've seen contamination of zinc from putting it into a galvanized container before putting it into a bottle. I've seen silicon contamination by sampling through a silicone hose into the sample bottle. So you just want to make sure you're just have a really clean environment and that you're doing as close to operating temperature as possible. And also sampling before the filter. Don't sample after a filter. What is the best way to show a customer the types of reporting available to them? Good question, Joel. Probably need to put together like a little marketing PDF that shows all the different ways. That might be a really good thing for us to put together. So appreciate the feedback. There's a lot of different ways we can send off PDF reports. They're one PDF per email. We can send off summary emails. So if you get a lot of samples at one time, maybe you're getting 20 in a day, we can put those all in one email, and there's a hyperlink that goes straight to these PDFs, which makes it really quick and easy. You can obviously go pull them off of our website once you're set up there. So there's a lot of different ways. Seems like it'd be good for us to put together a guide. So appreciate that question. Toby, we have compressors that have a fresh oil tank that feeds the engine when the level in the motor drops below a certain level. As this auto oiler feeds the motor, can this have an adverse effect on the oil sample analysis? I'm familiar with that. So I'm familiar with, with those compressors and sometimes natural gas engines. I believe the term is sweetened. I might be wrong, but I feel like that's a term that's used with you guys, that you guys are constantly kind of sweetening and topping up those tanks. It can, and that's where, if there is a way for you to know from your end, Toby, it'd be good to note it. So if there's a way that you can kind of understand that maybe however many gallons or quarts were possibly fed in between sampling, I don't know if there's an easy way for you to monitor it, but that's where you'd want to note that on the form. Obviously, it'd be something to be concerned about is if from your perspective. So one thing to understand, Toby, is if most of your compressors are being supplemented at the same rate, what's really nice is you can kind of use your entire program or fleet of compressors to kind of get an idea of if one is in an abnormal way or not. And that's something we're going to do internally as well. Usually our diagnosticians are reviewing lots of reports within the same group of samples. So they're going to see all of your compressors at once if they were submitted together, and they'll be able to identify if something doesn't seem correct. So really good question. Big thing on your end would just be monitor, is a compressor being supplemented with fluid at a more accelerated rate than others? That's where something you'd want to communicate with the lab. Steve, wow, we got a lot of questions. This is good. Steve, is an abnormal diesel fuel test result indicative of dirty fuel, or is there more to it than dirty? They will deny any warranty issue with an abnormal test result. It could be. Now, the reason I say could be is if you do have dirty fuel, that dirty fuel could be causing perhaps an injector to stick, and maybe that injector is leaking and causing excessive fuel to get into the cylinder, which then kind of seeps down through the cylinder wall into the sump of the engine. So that's a really good question. So that's one way dirty fuel could contribute. Also, maybe it's not fully combusting because it's maybe not a high quality fuel, and so that fuel that isn't combusting maybe is getting into oil. So that is a possible cause, but it's not the only one. So I wouldn't necessarily say that dirty fuel is the reason that you have high fuel. It could very well just be from a bad injector, or maybe the engine is idling a lot. So there's a lot of different ways. And so that's where that investigation begins. And ALS does test fuel. That could be something we do a webinar in the future, is looking at fuel quality. Because there are ways to look at how your fuel meets ASTM requirements. Daniela asks, if there is a coolant contamination, is it always indicated by an elevation of sodium potassium without labeling coolant section as yes? The majority of the time, yes. Sodium, potassium, there are a couple other elements. Sometimes boron and silicon can be an indicator of coolant leaks. But usually you're always going to see those elements. It's very rare that we don't see those certain elements that indicate a coolant leak. But usually we'll find that in other ways if there is a coolant problem. Matt asked when are we going to open Kansas City to diesel fuel testing? That's a good question. That is something that we're looking to keep diversifying our the capabilities of our laboratories. But that's a really good note. So I'm going to note that down about Kansas City, because if there's a need for us to up the amount of diesel fuel testing we're doing there, definitely all for it. So appreciate it, Matt. All right. Mark, in situations where the oil is in a machine for a long time but does not get used for very many hours, what is the indicator that would tell you that an oil change needs to occur more frequently? All right, let me think through this real quick. That would just, what you'd really want to look at with that one, Mark, is if it's in for a long time and it doesn't get used, you'd want to think about condensation. So what happens is if it's a piece of equipment that doesn't come up to operating temperature for an extended period of time, if that equipment is outside, the temperature change that occurs throughout the day could cause condensation to occur in whatever lubricant sump that there could be. So as that temperature changes, it's going to want to pull moisture in from the air, and then it's going to condense as the outside temperature changes. So that would be one thing I'd be afraid of is accumulation of water. The other thing is just natural oxidation that's going to occur. So in testing fluid like that, I would really check for contamination. So it'd be, is dirt somehow getting in? Is water getting in through condensation or rain? That rain, if it's equipment outside. And then also would be just natural oxidation. So if it's just sitting there, is it slowly oxidizing? So you'll want to run perhaps an oxidation test or a total acid number just to see if physically that oil is changing. So hopefully that was some good information for you, Mark. But definitely feel free to reach out if you want to chat about it more. Ramon asks, sometimes when you change from one brand of oil to another brand, even that they are the same viscosity, the oil pressure goes down. There is some reason for that. So the reason that could possibly be happening is usually inside of a viscosity grade. So if, for example, SAE 40, that the viscosity range actually goes from about 12 and a half centistokes all the way up to 15 or more. And so there can be quite a difference between some of the SAE 40 grade fluids. So, and I've seen some oils where brand new, that 15W40 is in the, a low 13 in terms of viscosity. And then you've got ones that are up in the 15. So there can be quite a difference. So that could be one of the reasons why, even though you're within the same quote unquote viscosity grade, one brand could just be running a lot on the lower side of that grade, and somebody could be running on the higher end. And so that's where you could be seeing some discrepancy in oil pressure. But it'd be interesting to know what that discrepancy is. So Ramon, if you've got more questions about that, feel free to reach out. We can kind of look at, is it just a small variation in oil pressure that you've just noted, or is it pretty drastic? Okay, Vishnu, when organic chloride contamination in engine oil, and what is its effects on engine? That one, it's a really good question. I don't really have a good answer for that, to be honest. I've never really dealt with that in my time with ALS, organic chloride contamination in engine oil. Yeah, that's something we've never really tested for in engine oil, and I wouldn't know what it begins to affect. So I'm going to definitely look into that, because I'll have to look into why that might be occurring, but it'd be good for me to know, because if that's going to start becoming an issue based on maybe new oils or how engines are being made, it'd be good to know. But good question. Sorry, I don't have a good answer for you. Why higher moisture shows when tested gear by coulometer? Now, you might want to reach out to me about this, Vishnu, but it would be interesting. So we do coulometric water by Carl Fisher testing at the laboratory. So I might need some more clarification on is it the laboratory that's showing that there's higher moisture in a gear, and why? If that is the case, then what you'd want to look into is kind of what I was describing before, is condensation occurring? So is that gear in an external environment where there's high variation in temperature that is allowing, because obviously if air can get in and you don't have a breather or a desiccant to dry out the air that's being pulled into that gearbox as that temperature and pressure changes, it could be slowly accumulating moisture in that way. Also, if it ever gets washed, sometimes we see wash water contaminate those. So there's a lot of different things. Will excessive DEF fluid show up in a sample? Good question, Dave. So DEF is water and urea. So it's really, what's difficult there is we've kind of started to look into that. I wish I had a better answer today on exactly kind of what we're determining is going to be the best way to figure that out. But it is something that is coming up more and more on, one, how to test DEF, and then how to deal with DEF contamination. What's really difficult there is DEF is obviously mostly water. So what happens is it goes in, if it gets inside the engine and then the engine heats up, it's going to boil off, it's going to heat up all that water and kind of make it turn into vapor and get out of the engine. And then you're not going to know. So you have to look at the traces of DEF that are left behind. So I'll look into that and hopefully I'll have a better answer in the future. But that is something that we're very aware of as DEF is more prevalent, is how do we test for it? How do we find indicators for it? So that way we can notify you if there's an issue. Alan, is the chart that shows allowable levels that we can compare actual test results against? So this is a question that comes up a lot, Alan. A lot of people ask, hey, I want to have something that I can compare to. There are some general tables that are out there. We usually can't share OEM specific ones. So if an equipment manufacturer has shared one with us, usually it's in confidence. They've said, this isn't to be widely distributed, and we use it internally. The other reason why we usually don't put out a lot of charts is there's a lot of things that go into the interpretation of a report. For example, a brand new engine, you might see a lot of aluminum, silicon, potassium due to the break-in. So you've got some aftercooler, some things from the aftercooler. I'm trying to think of the word, brazing from the aftercooler that leaches into the lubricant system, silicon from seals. And so if you were comparing it to a chart, it would look like it was a severe report. But there's a lot of other things that go into determining whether or not something is considered normal. And it's really difficult to put together a chart that says these are normal as long as all of these other 100 different scenarios don't apply. And so that's usually why we stick away from publishing a set table of here's what's considered normal, because there is a lot of what ifs or different conditions that contribute to the evaluation. And that's why we have diagnosticians. We have many full-time diagnosticians that review these reports, because there's a lot of things that go into interpreting a report than just looking at it compared to a table. Because if it was that simple, we probably wouldn't have diagnosticians evaluating reports. So we'd probably just issue a report similar to a blood test that just says, hey, as long as it's within these numbers, you're fine. But because there's so many unique things that apply on our end, we do an evaluation before we send it to you. So that's why we kind of stick away from tables, because we don't want to confuse you and make you feel that something is wrong when a lot of times there might not be. So hopefully that answers that question. Vishnu, but the same oil when tested on D95, it shows less than 0.05. D95, I don't remember that off the top of my head. I don't know if that's water by distillation. So yeah, Vishnu, definitely email me if you got my email there. Definitely send an email and we'll consult more about what you're dealing with. Last question, Robert. In the reports, are the diagnostics tailored for each sample, or is there a standard reply based on results? Good question, Robert. Sometimes it might feel to you that there's a standard reply. We do that for efficiency reasons on our end. So many times, as a diagnostician, I review hundreds of reports a day. I would take my time on them, but so for sake of time, we use special codes that allow me not to have to hand type out hundreds and hundreds and hundreds of words. just to do a few reports, I can type in a few various codes that have designated phrases based on what I'm interpreting from it. And we have hundreds and hundreds of different codes and scenarios that apply to everything. And so that's why on your end, it might feel that there's a standard reply. But if there's a name at the bottom left of an analyst, that means that somebody did look at that report. They reviewed everything. And even though everything might be normal, they're the ones that hand typed out those comments. So sometimes it feels standard, but most time there is somebody reviewing, and the reason that there's standard phrases is just due to time. Just it really speeds it up for us because we see a lot of the same things over and over, and so you can imagine typing the same thing over and over would become quite tiresome. So it's purely out of efficiency, but I can assure you that, especially when the report isn't normal, if it's abnormal or severe or caution, that those diagnosticians are reviewing it and tailoring exactly what it says based on what's going on. Ryan asked if base number is the be all end all. No. So what's really interesting is base number was a really popular test done on diesel engines oils over many decades. And it's still probably prevalent for some of like the older style fluids that are kind of still using additive packages that are kind of based on the old CJ4 style, pretty heavy additive package. But what we've seen is as engine lubricants have advanced over the years, they're becoming super resilient. You can drop those base numbers way lower than you would have ever thought you could 20 years ago, just because of how well these fluids are formulated, their base stocks, their additive packages. And so what we've begun to do in some programs with some customers is we've began to run acid number. So instead of looking at how that additive package is being depleted, we're really looking at what it's trying to counteract, because we know that the thing that you're trying to combat is acid buildup. And so instead of trying to track this base number that it seems from what we've seen can keep going lower and lower and lower as these great fluids come out, we really just need to look at how is acid building up over time. And so instead of running base number on a lot of new diesel engines, we're starting to run acid number. So we're looking at how that acid is building up over time and how it's having, because that's what's going to contribute to the negative effect, the oxidation of the oil. Perhaps the acidity reaches a level where it begins to, eat at the bearings themselves or the different metallurgy of the engine. So it's maybe back in the day it was the be all end all, but we're definitely seeing that change over time. So hopefully that answers your question, Linda. All right, that was great. I really appreciate all the questions, everybody. It was really great to be here. Hopefully some of you can reach out to me if you've got more detailed questions, and look forward to it seems like we have a lot of good ideas for new webinars, so I appreciate it.
Thanks, Quentin. And I just want to thank everybody for attending today. Again, you can contact Quentin for any questions. His contact details will be in the email following the webinar. That'll be along with the recording of this webinar, and I will also send out those links to those tools that he was discussing. Hope everybody enjoys the rest of their week.
Thanks, everybody.